Alright, welcome back. We've got 8-1. And this is part 2. We are talking about vectors. I'm just going to say 8-1 part 2. Alright, now we are going to draw several vectors, and then we're going to talk about what's happening. So we're going to take this space here to draw some vectors, and then we're going to write about them here on the right. So we're going to draw several here. We're going to draw one that is at kind of an angle here that's 1 inch. Don't forget the arrow. And this is vector A. Now we're going to do another one that's at the same angle. We're trying to make it be at the same angle. And we're going to make that 1.5 inches. And that one's angle B. That one is vector B. And then we're going to draw another one here that's not the same angle, but we'll make it 1 inch. And that one is I keep saying angle, vector D. Now let's do another 1 inch vector that is the same angle as vector A. And the same length, 1 inch. And this one is going to be vector C. Let's draw, we're going to draw two more. One more here is parallel with C and the same distance, but it's going to go the other direction, and this is going to be E. And the last one, we're just going to draw, it parallel to these guys, but we're going to draw 2 inches. And it's going to be going to the left, and this is vector F. Alright, so the cool thing about this is you can pause this and make your work look like this, and I can just keep going. We're going to talk about parallel vectors. So I'm going to look at this. I've got A, B, C, E, and F. Those are all parallel. They're all going, they will all never meet, no matter how far they go, right? These are all parallel. So A is parallel to B, which is also parallel to C, which is parallel to E, which is parallel to F. So all of these are parallel except for D. Poor sad D. Now, we're going to talk about equivalent vectors. And so equivalent vectors have the same magnitude and direction. Same magnitude. So if you remember, magnitude is the distance from the beginning to the end, from the initial to the ending point here, which, what are we calling the ending point again? Terminal. Initial point to terminal point. So the same distance here. So magnitude and direction. So I've got A and C, they have the same magnitude and they're going the same direction. So A equals C. Now let's look at these other ones here. C and E have the same magnitude, they're both 1 inch, but they don't have the same direction. So C does not equal E. Now E and F are going the same direction, but they don't have the same magnitude. Let's see, A has the same magnitude as D, but they're not going the same direction either. So A and C are the only equivalent vectors here in this example. Opposite vectors. So opposite vectors have the same magnitude and opposite direction. Goodness. Opposite direction. So let's see here. The way we write this is, so I have E here, and I've got A. They have the same magnitude. They're both 1 inch. And A is going that direction, E is going this direction. They're going opposite directions. Not just different directions, but actually opposite directions. So one is going one way and one is going exactly the other way. So we write this as E equals negative A. So if I was to flip A, then they would be both going the same direction. They would both be going the same direction, right? So I say negative A, E equals negative A. That's how we say these are opposite vectors. Okay, now let's go on to another part here called the resultant. The resultant is the sum of 2 or more vectors. And it is found by two different methods we can use. So whichever one you're more comfortable with, we're going to learn them both. The triangle method which is tip to tail. And then we also have the parallelogram method. And this is tail to tail. And this will make sense in a second, hopefully. Alright, so let's start with our vectors here. So we're going to say vector A. Oh, you don't need to use a ruler. We can just eyeball these. This is okay. So I'll say I have A is going down this direction like that. Vector A. And vector B is going this direction like that. And we'll be using the same A and B. A is going to be like this, and B is going to be like that. Alright. So now let's look at the triangle method first, and then we'll look at the parallelogram method. Triangle method, step 1. I just take the tip and the tail and join them here. So I've got A is going that direction like that. And B, I just move it over like that. And so that's step 1. Step 2 is I just take this part of a triangle, A and B, and then I draw this across, and so this becomes A plus B. So I need a arrow at the end of it. Maybe we should just darken that in there. I like that better. So A plus B is the resultant vector when I add A plus B. So that's the triangle method. Now let's look at the parallelogram method. Step 1. What we do here is we take the tail and we butt that up against the other tail. So I've got B is coming back like this. Oops. Like that. There's B. And then A is going just like that. Notice I'm just trying to take this piece and put it there, take that piece and put it right there, so they should be the same. And then what you do is, we do that, and then step 2, we orient them this way, and then we got to draw them again. B, A, and then what we do is we complete the trapezoid. Complete the parallelogram. So I just draw B again. There's B again. And I draw A again over here. And they should match right there. Then step 3. I've got B. I've got A. I've got B again. And I've got A again. And then I draw. From the tail here to this new point that we created, and this is A plus B. Personally, I think this way is way easier and faster than this way. But the book shows both of these, so I thought I should show you both of them as well. Let's do some examples. All right. Tia walks north 50 degrees east for 120 feet. Then 80 feet due east. How far did she go? And at what bearing? What quadrant bearing? Is the resultant. All right, let's work this out. Okay. North, east, south, west. Okay, so she walks north 50 degrees east. So we start north and we go 50 degrees east. So we're going to the east, so that's this direction, 50 degrees. So 50 degrees, so this is 45, so just a little bit farther than 45. All right, 50 degrees. And she walks 120 feet. So we have to decide what our scale is going to be. So for 120 feet, let's see, let's do an 1/8 of an inch. I should get a ruler with centimeters on it, so that that'll be easier. But anyway, here we go. Let's do, so let's say every 10 feet, ooh, I should give myself more space here. Every 10 feet is 1/8 of an inch. So I need to go 12 of those. Okay, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my spot. There's my first vector, and I need to write down 1/8 of an inch equals 10 feet. All right, so now I'm going to go due east. So that is parallel with my east here. So there's my east. And so I need to go parallel to that east. $80. So that means 8 1/8 of an inch. All right. 1, 2, 3, 4, 5, 6, 7, 8. 8 1/8 of an inch is 1 inch, of course. All right. So this was the first one. Here's the second one. 80 feet due east. Oh, due east. All right. Now we need to know. So if this one is A and this one is B, we need to know this one, which is A plus B. We go from the starting point to the ending point, the initial side to the terminal side, or point. That's right here. So this one is A plus B. So we need to know this degree measure, right? We need to know what bearing we have. And we need to know this distance. So we want to know how far, and we want to know what is the new bearing. So let's measure this, how far we go here. So we've got 1 inch, 2 inches, 1, 2, 3, 4, approximately 4/8. 1, 2, 3, 4. Okay, so we've got 2, and I'm going to keep it in eighths because it's going to be easier that way. So if I have 2 4/8, which is 2.5, how many feet have I gone if each 10 feet is 1/8 of an inch? So I can split this up. So each inch is 80 feet, right? So 1 inch equals 80 feet because there are 8 1/8 of an inch in an inch. Man, good luck following along. All right, so that means if I have 2 of those, 2 inches at 80 feet per inch, then I have 160 feet plus 4/8. 4/8, so that's 40. So 160 plus 40, we get about 200 feet. So that's about how far she went. Now, at what bearing? We got to figure that one out. How are we going to figure out this distance here? So the way that we do that, so we could set up a triangle here, right? We could find this distance here, we could find this distance here, and then we could use the Pythagorean theorem to find this distance here. We could get out our protractors, which is what I think is going to be the best way to do this. And so if you were to get a protractor out and you lay that on top of here, then you would get about 65 degrees here. So this angle is going to be about 65 degrees. So we're going to have a bearing of north 65 degrees east. And sorry, I don't have a protractor for you, but I also think it is going to be a lot of effort and time to try to figure out the exact value of this without using a protractor. And we're being fairly approximate here anyways. So so that's what we'll do. We'll have to figure out a way to get you a protractor if you don't have one. All right, let's do it. Let's have you guys do one. You try. Mr. V goes surfing. He paddles out due west 80 feet. And the current pushes south 20 degrees west. So I need to know what is the distance. The current pushes Mr. V south 20 degrees west 50 feet. How far did he go? How far did I go altogether? Distance. And what is my angle? So hopefully, or my bearing. So hopefully you have a protractor. I don't even have a protractor here. I have to look for one. But I have my notes from last time to help me. So let's draw. This time we're going to be a little more precise with our bearing, our north, east, and west. North, east, south, west. Okay, so Mr. V paddles 80 feet due west. So we're going west 80 feet. All right, so let's say 80 feet. Let's do a quarter of an inch. Will that work for each 10 feet? 1, 2, 3, 4, 5, 6, 7, 8. Yep. So we're going to say quarter inch equals 10 feet. So we go 1, 2, 3, 4, 5, 6, 7, 8. That's 80 feet. And the current, so now that I've gone 80 feet, we're going to draw a new south, north, east, west mess here, because this is how this works, right? So I could put a 20 degrees here, where that's 50 feet, or I can move it here to go 20 degrees, which is about right here, and make that one go 50 feet. So I'm going to have to move it here anyways to be able to connect them. So I might as well just start it right here at the end. So what I'm going to do is I'm going to find 50 feet. So 10 feet is a quarter inch, so I need 5 of those. 1, 2, 3, 4, 5. There are 5 quarters of an inches, which will get me my 50 feet. And this is 20 degrees here. Whew, all right. Let us draw our new vector, our resultant, and measure that thing. All right, let's measure it. How many quarters of an inches are there from here to here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 quarters of an inch. So that'll get me about 110 feet. This is 11 quarters of an inches, 10 feet. All right, and now this angle here, I want my new angle. And I'm just going to tell you, it's about 66 degrees. And so there. Now we need to know what the bearing is here. So I start from south. So south, 66 degrees west. is my answer. So I've gone 110 feet at south 66 degrees west. All right. There's a lot to this section of the chapter. We're going to take a... Oh, you know what? Let's go ahead and do a couple more you tries here. Going? All right, you try. So my vector A, north 35 degrees east at 100 feet. And then vector B, due east 50 feet. Okay, so I'd like you to go ahead and try this one, pause it, and then come back and we'll do it together. All right, let's see how you did. So let's go ahead and draw this guy. All right, we've got north, east, south, west. So vector A is 35 degrees. So we're going to say this is about 35 degrees right here. I'm going to draw that fairly lightly. And that is at 100 feet. So let's decide that, let's see, we're going to go 150. So an easy way to do that would, let's say 25 feet equals a half an inch. So we'll say half inch equals 25 feet. So that means for 100 feet, I need to go 2 full inches, or 4 25 feet. 25 feet? All right. 1, 2, 3, 4. Ooh, ugly. All right, there it is. 100 feet. And this is northeast, so from the north to the east, that is 35 degrees. Now, there we go on there. Yep, okay. Now I need to do the due east at 50 feet. So due east, so that's going to be just straight, parallel with east, 50 feet. So that is 2 half inches, or 1 full inch. So this is 50 feet. And then I'm going to connect the tip and the tail like that. There's my new vector, my resultant. And I'm going to measure this. How many half inches are there here? 1, 2, 3, 4, 5 and a half. So I got 5.5 half inches. So 5 half inches will get me 125 feet, right? And a half an inch, we'll just say it's 12 and a half. We'll say it's 12 and a half, right? So 12.5. So I've got 137.5 feet. So I've got about 137.5 feet is my distance. And then I would like the measurement from here to here. So if you had a protractor out, this distance from here to here would be around, let's say, that's about 40 degrees. So it's about 40 degrees. So we've got east going north, right, is about 40 degrees here.